Okay, well, we set up a little experiment like Mag was doing. The results aren't quite as good as his. For two reasons. I'm just using my Super Dual Ringer 2 coil, which is 20 turns of thick wire on one side and 200 turns of thin wire on the other, so not really set up for a dual feath configuration. And we are only drawing 32 milliamps. Uh, 12.41 volts in the run battery, but nonetheless the results are the same. This is our output, this is our input. As you can see, this wire here is going back to our amp meter, which in turn is hooked to the battery. They are two identical light globes, and being incandescent, they are really just a resistor that gives off light in the form of heat through the tungsten filament. You can see if I undo this globe here, it does indeed stop. We will swap the globes without touching anything else. We'll put this one over here. This one that we took from there we'll put back in here. And we will put this one back in here. If I can get it to screw in. There we go. And the results are the same. So at the moment I have no answers for you, Mag, other than to drive the same resistor, but one hotter than the other. As you can clearly see, this one is hotter, means this one must be getting more current through it, and this is our input current. And that is our output current, which is coming from the collector side of the transistor through the two 4007s and into our light globe. Of course, the other side of the light globe is hooked on to the output side of this light globe. So we can, of course, make that one grow nice and bright, but we can tune it so as there's less current in this one than there is in that one. So the other thing is, we can now, I'll just disconnect that before I disconnect the load, put this onto a battery. We'll swap these over so I don't get confused. We'll grab a white one, so instead of the light globe we should be able to charge a battery with it. So our battery has 11.94 volts. And this one has 12.43 open. We will start her up. You can see the pitch changes. So the system at the moment is drawing 51 milliamps. 12.4 battery is indeed being charged. So theoretically, with more current coming out of this side, according to our light globe, than is what's going into that side, this battery should charge up faster than this one here discharges. So what am I going to do? 12.4 on our run, 11.96 we'll say, even though it was 11.94 on our charge. We will leave that and see what happens. So that's my results, mag. Yes, I don't know why there's more current on the output than the input, but I've even gone to the trouble of swapping the globes over so we can see that there was no inconsistency in the globes and the results were the same. The output globe will light and the input globe will not. So perhaps there's someone else out there that's got some ideas, shed a little light as to how we can have more current on the output than current going through the input. Okay, well that's it for now. We'll let it run and we'll see what happens with these two batteries. Cheers from the Tin Man. Okay, so battery's been charging for a couple of hours now and I'm going to let it sit for half an hour just so we can get to its rest voltage. So still looking at the output side of this system that Mag's been playing around with. What I'm going to do now is measure the voltage across our resistor, which is our light globe, both on the input and the output. I'm then going to hook or put the globe into this socket here. I have a 220 ohm resistor, 5 watt, and these globes are only 1 watt, so that will more than compensate for any heat loss. We'll then hook the power up to this setup through our multimeter, measure the voltage across the globe and the current that it's drawing. So we'll just give this a kick in the guts. We'll turn our meter on. So as you can see, that one is glowing, this one is not. That is our input one there, as you've seen before. So across that globe at the moment we have 0.925 volts. So because these two pins are linked via this, we can take this off to measure the voltage across this globe, which is not glowing, and we can see why it's not glowing because there's only 0.302 or 302 millivolts across that globe. So once again across this globe that is glowing, which is our output, we have 930 millivolts, and across this globe, which is not glowing, we have 305, 306 millivolts. So that tells us why this one glows and this one doesn't, because there is not enough current going through that at the moment to make it glow. So that is interesting. So what I'll do now is I'll disconnect it. I will take this globe out, where you will use this one. Just so you know there's no hanky-panky going on. We'll hook our negative to one side with our voltmeter. Actually, one thing I did not show you while we were doing that test, which we will start her up again so you can have a look. And that was the current draw on the system. So like before, 0.930 or 930 milliamps across that one. Yep. Have about 309 milliamps. Let's say 310 because it is slowly climbing. Which would mean that the element is slowly heating up, and of course your resistance then becomes less once they get hot. But she's slowing down now. So we'll say 311 millivolts that may climb to. Now our current draw is 29.5 milliamps on the 200 milliamp scale. So that is our current draw, 25 or 29.5 milliamps. So what we will do now is hook it up into this little straightforward test unit. Like I said, we will use the globe that we were observing. Get a meter up across this globe. And our amp meter. Okay, now I'm limited to these big resistors. The only other one I've got is a 100 ohm, and that is too much. But anyway, as you can see, as the element warms up, the resistance becomes less, so our voltage becomes more across the globe. So we'll let that go for a little minute. But there's the current draw, 56.9 milliamps, and we're nowhere near the voltage required that was being used to light up the globe coming out of the system. So that's pretty much well stabilised now. So there's 376 millivolts. So 377. As you can see, the globe is not glowing, and we are drawing a lot more in current as far as this system uses. So for 57 milliamps from our 12 volt battery, we can only achieve 377 millivolts across that globe, whereas if it's on the back side of the system or the power outside of this system, for less input current we can achieve a higher output current. As far as our testing goes so far, I'm not aware of any other way to do this. So every test shows that we are indeed getting more out of this system than we are putting in. And once you say that, you wait for the rain clouds to open up and for the experts to move in. So hopefully someone can explain as to what is happening. So in this situation we are getting 377.8 millivolts across our globe. Our globe is not lit. We are drawing 57 milliamps, and once again using the very same globe, just in case there is a little bit of difference. We hook it back to how we had it. The globe is indeed lighting. And we are around 918 milliamps across the globe now. And we are drawing just a bit over half of what we were with this setup. So that's it. Up until now, no answers of yet, but still looking. If anyone else has a test they think we could carry out to confirm what's happening here, let us know. Cheers from the Tin Man. Okay, rest voltages. Just a quick one on this. They have only been sitting for about half an hour, may change, but they are only 7 amp hour batteries. They're both identical batteries, mind you, both 7 amp hour batteries. 12.22 from 11.96 on our charged battery. If you've seen at the start of the video, I forgot to put the 3, and I'm pretty sure it was 12.43 when we started, and even after our little testing we done just a minute ago, it's still sitting at 12.43. So it just gets a little more interesting every time. But anyway, we'll keep slogging away at it and see what else we come up with. May just leave it charging overnight and see how it goes. Cheers from the Tin Man.